Okay, brother. So if we look at this one, we will see that the power of this one and the power of this one, they are the same. So if they have the same power at that point in time, so what we just do is we need to divide both sides. We need to do long division. You get me? So to do long division, we just need to draw our normal long division. Um, I don't know what to call it. Radical sign. Plus 7s plus 9. So this is going to be 5. So the one that is going to divide, this is the divisor. It's going to be here. Then the dividend, s raised to the power 3 plus 2s squared plus 4s plus 1. So that one is going to be within this, under this radical sign. So at this point, we now have this one dividing this. So we're going to start with the first one here, which is s raised to the power 3. It will divide this. That is 5s raised to the power 3 divided by s raised to the power 3. So that's going to be 5. So 5 times this s raised to the power, that will be 5s raised to the power 3. 5 3, that will be 10s squared. 5 times 7, that will be 35s. 5 times 9, that will be 45. So once we do that, we now subtract the 2. So this 5 minus 5 is 0. 2 minus 10, so that will be minus 8s squared. Then 4 minus 3 minus 35, so that will be minus 31s. Then 1 minus 45, so that will be minus 44. So now that we have this, our C of S over R of S is now going to be represented now. Since now that the power of this one is now less than the power of the divisor, so it is now in proper fraction form now. So we are going to represent it as the value that we obtained, which is our quotient. Then the remainder, that will be minus 8s squared minus 31s minus 44 all over the divisor. That will be s cubed plus 2s squared plus 7s plus 9. So we have the quotient, we have the remainder, and the divisor. So this is how it is going to be represented. And if you look at this very well, you will see that if we are kind of trying to find the outputs, 5 will multiply RS and 5 will multiply this entire one. You get it? So it can be represented like the C of S will be 5 R of S plus the minus 8s squared minus 31s minus 44 all over S cubed plus 2s squared plus 7s plus 9 R of S. So this one as it is now, it means we can represent this if we want to use our state space equation to represent it now. So we know that this is going to be this is having s cubed there. So our state space representation will be x1 dot x2 dot x3 dots. So that's going to be 0 1 0 0 0 1, right? Then this is going to be minus 9 minus 7 minus 2, right? So it's going to be x1 x2 x3 then plus, so our arrow is going to be 0 0 1, right? So our output is now going to be the top here, the numerator here, which is going to be minus 44 minus 31 minus 8. So it's going to be y1 y2, sorry, x1 x2 x3. So this is our representation. So if you want to draw the SFG, so the SFG of this thing, if you look at this very well, you can see that this is addition of this and this. So it's just like in normal cascade, what's it called, parallel form. They are adding. So that's the way we also going to attend to this one too. So but the first thing we'll do is let's do this major one, which is this one. carry everything. So we start with our C of S, which is our Y of S. So we go. So from our Y of S, so we have x1, we have x2. No, sorry, x1 dots. I like to do that, put everything plain so that we can see everything. Then x2 dots, then x3, then x3 dots. Then we have our arrow. Now, as this one is now, we want to represent everything under x3, right? So let's focus on our x3 first. So our x3, so we can do all this 1 over s. Yes. Okay. Now, so if we want to link these ones together, so we see that for our x3, so this is x1 multiply this, right? So x1 goes from there, it goes to x3, right, which is this minus 9. Then this minus 7 multiply s2, right? So x2, that's minus 7. Then this minus 2, that's x3. So that's this minus 3, and minus 2 rather, right? So that's for this one. So the numerator, that's the one above, the output, will do those ones at the top. So the outputs now for this one, we have x1 minus 44. So it goes to the outputs. So x1, so it's going to be minus 44. Then minus 31, that's for x2. So it goes from here to x2. So that's minus 31. Then the x3, which is what? Minus 8. So it goes from here. So that's a minus 8. So that's how we link those together. Now the last thing we want to do is this ROS. It also links the output to the input. So it's just like it goes from here. So you can see that. So it goes from here and goes to the inputs. You get it now. So it links everything together. This is going to be 5. You get it? So they are a kind of in parallel like that. So that is how this is going to be represented.